set selected counter, and we're going to receive a clear counter for the selected counter. Then over here we just set this dot selected counter, so we're modifying the member variable with the one that we receive on the parameter. And then let's also fire off the event. So let's copy paste the event just like this, the exact same thing. Okay, so that's it. And now up there, instead of code duplication, we just do this. So over here we set the clear counter, just call the function, pass in that one and get rid of this. And on that one, just pass in null, just like this, get rid of all of this. And here the same thing, just pass in null. Alright, so with this our code is much cleaner and everything still works exactly the same. So here we have everything done on the player side. Let's just get rid of our log, we no longer need this. So we're still handling the selected counter logic, and then down here we're firing off the event. Now all we need to do is go over here into the selected counter visual script. And here what we want to do is to listen to that event. And in order to do that, we need a reference to the player object. Now so far when we've been listening to events, like for example on the player class, up here we were listening to some events on the game input, so there you go, the onInteract action. So for the game input reference, we just added it as a serialized field. We did this and then we dragged the reference directly. And technically we could do the same thing over here on the selected counter visual, but we're going to have like a dozen counters in our map, so it would be pretty tedious to drag and drop the player reference to every single one of them. So instead of using a serialized field, another approach is to use the singleton pattern. This one is an extremely useful programming pattern. It's very useful for things where you only have one instance of something. In this case, we're making this game single player, so we're only ever going to have a single player. By the way, here's one obvious quick note. Like I mentioned in the beginning of this course, after this video, there's going to be another one converting this game into multiplayer, and in that case, we will have multiple player instances. But this is also an excellent reminder of how refactoring code is perfectly fine. For right now, for this game, it is intended as single player, so for now we're going to use the singleton pattern. Then in the future, when we convert this to multiplayer, we will simply refactor that logic. Again, don't be afraid of refactoring code. It's a perfectly natural part of programming and game development. Okay, so let's implement the singleton pattern. This is actually super simple. The name sounds intimidating, but it really is very simple. Over here on the player script, let's make a public field. This one, let's make it static. If you don't know static, basically it means that this field belongs to the player class itself and not to any instance of a player. So for example, if you had 100 players, you would have 100 instances of move speed, you would have one for each player, but there would only be a single static field because this static field belongs to the class itself and not to any instance. So let's make a field of type player, and then for the name, the convention is to call it instance. And the reason why I'm using Pascal case here, so capitalized in the beginning, the reason for that is because this is actually not going to be a field, but instead it's going to be a property. Remember the naming rules that we covered in the beginning of this course. It's very important you follow your naming rules. Always be consistent so your code is easier to understand. So with that said, since this is the first time we're using a property, let me quickly explain what it is. Basically, it's the exact same thing as a regular variable, except you can add some logic when getting and setting that field. So here let me write some quick code just to show the difference between a property and a regular field. So for a regular field, you would call this maybe instance field, something like this. So this is a regular field. Then you would have some kind of public static return a player and call it get instance field. Then over here you would return the instance field. And then maybe another public static void set instance field, where you receive a player for the instance field, and you would set the player.instance field into this instance field. So this is how you do this logic with fields. And now with properties, you would do public static player, then call it instance. Then on the property itself, you open up the curly brackets. Inside the property, you put a get, then you return something. So for that something, usually a property has a field underneath it. So you'd have a private static player for the instance. That's a different name from this one. On the get, you would return that. And on the set, you would set the instance equals the value. If you're confused here, don't worry. Basically, I'm just repeating just so you can see the difference. Here we have a field with a get and a set function, so regular functions. And up here we have a property, and inside the property itself has a get and set functions, which can also do some logic, so you can do some logic in between, or you can just return the underlying value. So basically using a property is pretty much the exact same thing as using a separate get and set function. Also, one more bonus thing, which is that C# is smart enough to automatically create the underlying field for a certain property. So if you just want to do a get and a set, then you don't need to define all this. You can just define a property, and then inside you can just do get and set. And there you go, this code here works the exact same thing as we had previously, which in turn is the exact same thing as all the code we have here with a getter and a setter function. So here it is, a valid functional C# property. Now, I have to say that personally I very rarely use properties. In fact, the only place where I use them is over here on the singleton pattern. For everything else, I normally use regular fields with get and set functions. Personally, that's just the way that I like to code, but that's really just personal preference. So if you do like to use properties, then go ahead and use them. Anyway, so the reason why I like using a property specifically for the singleton pattern is because the implicit implementation allows you to do something really nice. Again, remember the goal with clean code. We want to minimize complexity, and the best way to do that is minimize access. Here, if we set this property and we set it as public, then that means that any other class can both get and set, so anyone else can have both read and write access. So we have the exact same problems that I warned you about when I spoke about why you should not make everything public. And of course, if we make this private, then at that point we kind of lose the purpose of our singleton, since no one else will be able to access this. Basically, we want to be able to access this reference from classes outside of this one. We just don't want those classes to also have write access. Now, thankfully, properties have an excellent thing, which is you can define accessors for here, both the get and the set. So we can make the property itself public, which means by default, both of these will be public. But then we can also add the accessor over here private, which in turn means that the get will be public, so any other class can get this, but private means that only this class can set it. This way we have the exact level of accessibility that we want. This is the reason why for this specific use case properties are very useful. With just this one line of code, we already have our instance with the perfect level of accessibility. So now that we have this field, to set it, let's make a simple awake. So let's go over here, private void awake, and on awake we just set instance equals this. However, remember that a key point of the singleton pattern is you only have a single instance of something. So in this case, we should never have more than one player. If we do, then something went wrong. So we can add a nice safety feature here. Let's just check if instance, if it is not null, meaning it has already been set to something. If so, then that's an error, something bad happened. So let's do a debug.log error, because this should never happen. So let's say there is more than one player instance. This way we have a nice safety check just in case something goes wrong. Alright, so that's really it for the singleton pattern. We just define a property with a public get and a private set, and on awake we just set the instance. That's it. As you can see, it's super simple. And now for the really useful part. Over here on the selected counter visual, now we can access the singleton instance in a super easy way. Let's make a private void start, and on start we just access the player class, and from the class we can access the static instance, so we can access the singleton, and now we can listen to the onSelected counter event. And over here, by default, Visual Studio gives this function the name of the event and also the property. This isn't a very descriptive name, so I like to rename this, so Ctrl-RR, and just rename the instance here. Instead of instance, let's rename it to player. Okay, great. So over here we can listen to this event. However, here is yet another extremely important thing. Note how I made this on start. That is very important. If you do this over here on awake instead of start, and over here on the player, you're also setting the instance on awake. If you do that, basically there is a chance that this code will run before this code. And if that happens, well then this one, the player instance, has not been set yet, so this will be null and it will throw a null reference exception. Now whether this happens or not is actually somewhat random. It depends on the order in which Unity decides to run both these scripts. If Unity decides to run the player first and this one second, if that happens then there's no problem, but if Unity decides to run this first and then this one, then we have a problem. Let me do a quick test and see if in my case it triggers that error. And yep, in my case it did trigger that error. So here we have a null reference exception. And yep, it is being fired on this line. Now, one solution to this problem is you can tell Unity specifically which order the script should run in. So you can go up here into Edit, then go into the project settings. Then on the left side, you've got something called the script execution order. And basically over here, you can set the order in which all of these scripts run. So if you were to make the player script run before the default time, that would make sure that even though both these scripts are on awake, this one would run before this one. So that would fix that problem. However, you should really only use this approach in the last case possible where there really is no other way. In this case, we do have another better way. Personally, I have a very simple rule that I like to follow that helps solve this issue. As you know, Unity has both an awake and a start. And all of the awakes on all the objects will all run before all of these starts. So the simple rule that I follow is that I use awake for the initialization of that script, and for any external reference, for that I use it on start. So in this case, for initializing the player and setting the instance, that relates to the initialization of the player, so let's do it on awake. Whereas over here on the visual, since here we're going to access the player, which is an external reference, for this one, instead of doing it on awake, let's do it on start. This way we are guaranteed to make sure that this instance has been set. Okay, so with all of that, here we have our instance, so that works great, and we have our event, so that's great. Then here we have our event, and inside we've got our event args, so we can go inside the event args object, and inside we have our selected counter. So all we need to do is just compare which counter this visual belongs to. So let's actually make a field up here. So as usual, let's make a serialized field of type clear counter. So we have this one, and before we go into the editor, just make sure it compiles. Let's comment this out. So now let's go back into the editor. And over here, let's drag the reference. But again, remember, we're working with a prefab. So let's click on open to go inside the prefab. And now whilst inside it, let's select the selected game object and just drag the clear counter reference. Okay, great. Let's go back outside and save the changes. All right. So now here in the code, it's actually very simple. So we just do an if the selected counter matches this clear counter. If so, then we want to show this visual. If not, we want to hide it. So let's also add a reference for that visual. So let's add another serialized field of type game object for the visual game object. Then back in the editor, again, let's go inside the prefab, and on the select, let's drag the child kitchen counter. So drag that one, that is the visual game object. Okay, let's go back, save, and back in the code here, let's make some simple show and hide functions. So private void show and a private void hide. And now on the show, just going to visual game object and call set active. So this enables or disables the game object. So for show, let's set it to true. And for hiding, let's set it back into false. Okay, so now it's super simple. If the selected counter is this counter, then let's show the visual. If it is not, then let's hide the visual. All right, that's it, super simple. Let's test. So here we are, and if I approach that counter, yep, there you go, look at that, the nice selected visual. And if I go into this one, yep, there you go, I can see it. All right, great. So here we added a really nice visual to our selected counter, and more importantly, we learned about the super useful singleton pattern, as well as learning about C# properties, and a very helpful rule for how to avoid code timing issues. So this was a really detailed, really important lecture. If you're feeling confused about anything, go ahead, watch it again, or just post a question in the comments and I'll do my best to help. So with all of this is all great. We have the selected counter and we can see which one is actually being selected. Then by pressing a button, we can actually interact with it. So I can move and interact with any of these counters. But right now, just interacting with them doesn't really do anything. So the next thing we need is to create some proper objects for all of our ingredients, so we can later pick them up and drop them on counters. So let's begin doing that in the next lecture. Hey again, quick intermission. You're past the 15 lecture mark, so congratulations. Looking at my regular course stats, it seems about 80% of people give up by this point, so great job with sticking with it. The difficulty and complexity is increasing over the lectures, so I just want to check in to make sure you're understanding everything. Remember to post in the comments if you need extra clarification on anything, and I'll do my best to answer. Also check the website to see what questions others have asked. And of course, remember this is your learning journey. You're not competing with anyone but yourself. So take your time, rewatch some lectures if you need to, just focus on learning. Okay, let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to create the kitchen objects like the various ingredients. Okay, so far we have our player, we can walk around, I can approach each of these counters, and I can interact with it. Now the next goal is to create objects the player can pick up and drop when interacting with a clear counter. So let's begin by making the actual objects. So let's create a new empty game object, call this one the tomato. Then again, as usual, let's separate the visual. So in the included assets, let's go inside of it. Then we've got the prefab visuals, and we've got the kitchen objects visuals. And inside we've got all of the ingredients. So let's just find the tomato visual and drag it as a child of the tomato. And again, as usual, make sure to put on position, local position 000. And for the main one, let's put it on a Y of 0 and just push it a little bit off to the side just so we can see. Okay, great. Now, this one is obviously not going to exist over here in our world. Instead, we're going to spawn it. So let's make it a prefab. Let's just drag it over here into our prefabs. Okay, there it is. Let's delete it from our scene. And actually on our prefabs, let's make a nice folder to keep things nicely separated. So inside the prefabs, let's make a subfolder. Call it the kitchen objects. Let's put the tomato inside of it. And let's also make another folder for the counters. And let's put the clear counter inside of it. Okay, so everything is nicely organized. All right. Now that we have this, let's go inside our clear counter script. And over here, let's add a simple reference to our prefab. So let's make of type transform, call it the tomato prefab. By the way, here you could make this prefab reference of type game object. Which type you use in this scenario is pretty interchangeable. I talked about those differences in another video. So when using prefabs, using them as transforms or game objects, that's pretty much personal preference. And personally, I just prefer to use them as transforms. Okay, so we have this. Let's just make this a serialized field so we can set it in the editor. And over here in the editor, let's open up, go inside the counter prefab and just drag the tomato reference. Okay, great. Let's go back outside, save. Now back in the code here, when the player interacts with it, let's just spawn it. So let's call instantiate, pass in the tomato prefab. And now here is a good question, which is where exactly do we spawn this? We don't want to spawn on this counter's origin. Remember that the counter, the way we set it up, the origin on the actual object is over there on the bottom. We don't want to spawn the tomato inside the mesh. That would not make sense. Instead, what we want is to spawn up here. So the next question is, okay, so how do we get this point on top of the counter? One approach would be to use a vector3 directly in the code. That would work, but not very usable. So a more designer-friendly method is to simply use an empty game object as a target. So on the counter, let's first go inside our prefab. And over here, let's create an empty game object inside of it. Let's call this the counter top point. Let's make sure to leave this one as empty, so no components, just a transform. And now let's just position it, so let's lift it up by just about enough, so let's make sure we see. So there you go, just about that. So let's put it on position, a Y of 1.3. Alright, so this point is going to be our spawn point. Let's make sure to save the prefab. Then back in the code here, let's add a reference to our point. And for reference, let's also use a transform reference. Call it the counter top point. Okay, now let's just comment this line just so the code compiles so we can drag the reference. Back in the editor, inside the prefab, let's just drag the counter top point reference. Okay, great. So now here, when we call instantiate, let's instantiate it inside the counter top point. So this will spawn the object, so let's say the transform for the tomato transform. And then we go inside this one, and let's just make sure we position it correctly. So let's put it on a local position of vector3.0. So this will put the object exactly on top of our countertop point. Also here, very important, don't make a mistake. Make sure you're modifying the local position and not the global position. Okay, so with this, let's test. Over here in the editor, let's go back, save our prefab, and hit on play. So here we are, let's approach the counter and interact with it. And yep, there you go, it does work. The tomato was indeed spawned. All right, awesome. Okay, so with this, we have pretty much our basics working. We can move up to a counter, we can interact with it and spawn an object. But now let's say that we want to spawn a different object. So let's say now we want to spawn some cheese. First of all, let's make the actual object. So on the tomato, let's press Ctrl D to duplicate this one. Let's rename this to the cheese block and let's go inside of it. Now in here, instead of the tomato visual, let's drag, here it is, the cheese block visual. So let's use this one instead. Okay, there's our nice visual. Let's make sure to save the prefab and go back out. And now let's say that we want this one to spawn a tomato and this one on the left to spawn some cheese. So let's override the prefab and over here drag the cheese block. And now if we hit on play, can go up to this one, and yep, there's a tomato, go up to this one, and yep, there's some cheese. Okay, so it all looks great. But now let's say we want to know what object we just spawned. Like what object is on top of this spawn transform. Just like this in the code, all we have is a transform reference. So with this, the only way to know what type we spawned would be if we had different prefabs for every single object. Then we could compare them one by one and see which one this matches. But then let's say, what if we wanted an actual string for the object? Well, then we would need to add tons of fields for all the strings for all of the objects. Then what about an icon for each type? Once again, we would need tons of fields, each one for each icon. But if we did it just like that with a bunch of lists, then they would be separated. That's not very good. We should have a proper way of defining our object types and all the data related to them. So this is exactly where scriptable objects come in. These are objects you can create in your project files, which are perfect for anything where you have multiple instances of a type. Like for example, multiple weapons, multiple armors, multiple recipes, or maybe multiple ingredients. As usual, I have a dedicated video on scriptable objects. They are super useful, definitely watch that for more detail. Over here, let's just use them. So the first thing we're going to need is to actually define the type, and we do that in a C# script. So in our scripts folder, let's create a new C# script. Call this the kitchen object SO. Now, personally, SO is just what I like to append to my scriptable object definitions, just to make it very clear that it's a scriptable object. However, this is not a requirement, it's just a naming rule that I like to follow. And we're calling this kitchen object because we're going to use this to define any kitchen object we want to interact with. So that's going to be our ingredients, like for example the tomato and cheese, but also things like a plate, and then potentially you could implement things like a frying pan or frying extinguisher or anything like that. So this is going to represent any kind of kitchen object the player can interact with. Okay, so let's make the script, and now let's open it. And over here, okay, first things first is this is not a mono behavior. Instead, let's extend scriptable object. And then technically you can have functions inside a scriptable object, but for now, let's just get rid of this, so just an empty class. And over here, let's just place whatever fields we need to store whatever data we want. So like I said, first we want a prefab, so let's make a public transform for our prefab. By the way, here note how I am indeed using public. This is pretty much the one exception to the rule. I only use scriptable objects as read-only data containers, I never write to them. So since I follow that rule, I usually make the fields in the scriptable object public. That way I can access them directly without having to make a public getter. But if you want, do feel free to keep following the general rule of not making anything public. You could definitely make this just a regular serialized field and expose with a get function, that would work. Personally, I just find it simpler to make it public, since I know that as a personal rule I will never write to a scriptable object field. Okay, so we have a transform for our prefab. Let's also add a sprite for the icon sprite. And finally, let's just add a simple string for the object name. Alright, so we have our scriptable object definition. We have all of the fields for all of the data we want to store. Now, how do we actually create a scriptable object? For that, let's go up here before the class name, and we're going to add the attribute, so let's add the square brackets. And the attribute is the create asset menu. This takes some optional parameters. Again, I cover them in detail in the dedicated scriptable objects video. For now, let's just leave all the parameters as empty, just use defaults and close the attribute. Okay, so that's it. Let's save this and go back into the editor. And over here, if we go into the project window, click on the plus icon, and right up top, yep, we do see a kitchen object SO. So if we select it, yep, there you go, it creates a brand new object inside of our project files. Let's name this one tomato. And obviously, let's keep our project nice and organized, so we don't want this inside the scripts folder. Instead, let's make a proper folder, so create a new folder, call it our scriptable objects. And then inside, let's put a different folder for each type. So let's make another subfolder, call it the kitchen object SO, and let's place the tomato inside of it. Okay. Now with the tomato selected, we can look in the inspector, and we can see, yep, it does have all of the fields that we defined. Okay, great. So now we can just assign them. So this is the tomato, so let's drag the tomato prefab. For the icon sprite, let's find it. So there are sprites included in the regular assets, so here is the tomato sprite. So it's inside the assets, then inside textures, icons, and we have all the icons. And finally, for the readable name, let's just call it tomato. Alright, so that's it. Here we have a really nice scriptable object containing all the data required for our tomato. Okay, awesome. With that then, we can now go back into our clear counter script. And here, instead of adding a field for our tomato prefab, instead of this, let's store a reference of type kitchen object SO, and let's call it kitchen object SO. And then when spawning, let's go inside our scriptable object and just spawn the prefab reference. So this is going to be the kitchen object transform. Then over here in the editor, let's go inside the clear counter and let's assign the tomato kitchen object. Okay, so let's save it and test. So here we are, let's approach, hit, and yep, there you go, it still spawns the tomato. Okay, great. Now let's make another type for our cheese block. So let's create a brand new kitchen object SO, call it the cheese block. And again, let's assign, first of all, the prefab, there it is. Then for the sprite of the cheese block. And finally, this is the cheese block. Okay, so now, for example, let's go into the second one. And on the second counter, let's override and say this one spawn a cheese block. So let's test. So here we are, approach this one. Yep, there's a tomato, this one, and yep, there's some cheese. Okay, great. So everything is working so far. However, the original problem that we're trying to solve, identifying the spawn prefab, we still don't have a solution for that. Basically, when we spawn a prefab, we need to know from which scriptable object this prefab came from. So essentially what I like to do is just attach some reference to the scriptable object in our prefab. However, again, remember that scriptable objects are not mono behaviors. So if I select the prefab and I try dragging the scriptable object, nope, it does not work. So what we can do is just create a new script. So let's make a brand new C# script. Let's call it kitchen object. Let's attach this to both prefabs, so both the cheese and the block, attach the same one to both of them, and let's open. And over here, very simple, let's just add a serialized field for our kitchen object. So a serialized field of type kitchen object SO for the kitchen object SO. Then let's also make a quick function to expose it. So we're going to return kitchen object SO, get kitchen object SO, and we just return the kitchen object SO. Yep, just like this. So now here in the editor for the tomato, yep, we've got the field. So let's say this one is a tomato, and the cheese block, this one is a cheese block. Now here, obviously, we need to make very, very sure to drag the correct reference to the right scriptable object. If you drag the wrong one, like for example over here on cheese, you would say this one is a tomato. If you did that, then obviously you would get some very weird results. So make sure to check and double check that you drag the right references. Both over here on the prefabs, make sure they are referencing the correct scriptable object. And on the scriptable object itself, make sure they are referencing the correct prefab. Okay, so now if you go here on the clear counter, we spawn our object. Okay, great. Then on this object, we can do get component of type kitchen object, and then we can just ask it to give us the kitchen object SL. So for example, let's do a debug.log on this one. So inside, get the kitchen object SO, and then let's print out the object name. All right, so here we are. Let's interact with this one. And yep, there you go, interacted and spawned a tomato. And on this one, yep, interacted and spawned a cheese block. Okay, awesome. We spawned a transform prefab, and we identified the spawned object is indeed this type of object. Alright, so here we'll learn about one of the most powerful Unity features, scriptable objects. These are extremely useful for defining a type and then creating multiple instances of that type with whatever data we want. So that can be some ingredients like we have here, or it could be some weapons, could even be some NPC data, maybe some quest data, and so on. It really is an insanely very useful feature. Definitely go ahead and watch the dedicated video on scriptable objects. Then if you want, you can also watch some more videos where I've used scriptable objects. For example, the Minecraft crafting system using scriptable objects, or the Hydroneer crafting system, which again also uses scriptable objects. Okay, so this is done, it's working great. Now let's continue to the next lecture, where we're going to help the kitchen object know where it belongs and help each counter know what kitchen object is on top of it. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a kitchen object parent, meaning that the kitchen object will know where it is, and the counter will know if something is on it. This is important so that later on we can pick up a kitchen object from one place and drop it in another. Okay, so here we have our player. I can move towards this counter, interact with it, and yep, spawn a tomato. Then on this one, spawn some cheese. Okay, great. But I cannot do anything else. In fact, if I interact a bunch more times, really all I did was just spawn a whole bunch more cheese. So instead, I want to be able to spawn some cheese and then pick it up. So let's think about exactly what that means. We want a kitchen object to essentially be placed on a specific place. Based on the design that we're trying to implement, we're never going to have a kitchen object just randomly strewn around the world. We're not going to have tomatoes all over the floor. Instead, the objects will always need to be placed somewhere, and that somewhere can be either a counter or it can be being held by the player. So essentially that means that each kitchen object is going to have some kind of parent that it's attached to. We're going to make sure the counter knows if there is a kitchen object placed on top of it, and we're also going to make sure the kitchen object itself knows where it is. So first, let's do that logic over here on the counter. So on the clear counter script, let's keep a field for a kitchen object. So just a simple private of type kitchen object. Then when the player interacts with it, by the way, we can get rid of these debug transforms, debug logs, we no longer need them. Okay, so when the player interacts, so if the kitchen object is null, if so, then we're going to spawn it. Then when we spawn it, let's assign it. So this one equals the kitchen object, get component of type kitchen object, okay? So if that one is null, we spawn it and we assign it. And just with this, we should have fixed the issue where we can spawn infinite objects. So over here, I can interact, and now if I interact a bunch more times, and now look in the hierarchy inside the clear counter, and I go inside the counter top point. Nope, there's only one tomato. Okay, great. So with this, basically, we made the clear counter know if there's something on top of it. Now let's do the other side. So let's go into the kitchen object and make sure that it knows where it is. So over here on the kitchen object script, Let's add a simple field for a counter, so private of type clear counter for the clear counter. And now let's just basically make two functions, one to set it and one to get it. So a public void set clear counter. And we're going to receive a parameter of type clear counter. Okay, great. And then we're going to have a public return a clear counter for the get clear counter. And we're just going to return our clear counter. And on this one, just set this.clearCounter equals this clear counter. All right, so on this function, we're assigning this field, and on this function, we're returning this field. So now back on the counter script, we get the kitchen object reference. So on this one, let's call setClearCounter and pass in this one. And if it is not null, so if there's something on top of this, let's just do a debug.log. Let's go onto the kitchen object and get the clear counter. So we should be able to click once and spawn an object, and click twice, and the second time we should be able to see the name of this clear counter. Alright, so over here let's approach and click, and yep, it spawned. Now click again, and yep, we've got the message. This one is on the clear counter. Okay, great, so far so good. So the counter knows if there's a kitchen object on top of it, and the kitchen object itself knows where it is. Now let's add some logic to be able to change a parent counter. So over here on the clear counter script, we basically just need to call the setClearCounter function with a different counter reference. So just for testing, let's add a serialized field for the second counter. So clear counter for the second clear counter. Now we're doing this just for testing, just to make sure the logic works before we come up with a more general system. So just for testing, let's come up with some input. And again, for testing, using the legacy input manager to get something quickly up and running is a great thing. So let's quickly get a button input on the counter. So let's make a private void update. And for testing, we only want the testing to work on one counter. So let's also add up here just a bool testing. And then on update, if we are testing and we have the input.getKeyDown on, let's say, the T key. So if you have that, then we can run some kind of testing code. So let's say, for example, if the kitchen object is not null, so if we have something on top of this kitchen counter, let's go into the kitchen object and call setCounter, and let's pass in the second clear counter. So basically with this, we should be able to interact to spawn an object, and then press the T key, and we should be able to see that object be set to a different parent. So here in the editor, let's just set that. Let's say this one is our main counter. So let's drag a reference to the second one, the second clear counter, drag it, and make this one the testing script. And also just to verify that it worked, over here, let's do a get on the clear counter. All right, so let's test and see. Okay, so here we are. Let's approach this one, interact, and there you go, spawn tomato. And now if I interact again, yep, it says the tomato is on this clear counter. Now if I press the testing key, yep, there you go, the tomato was moved onto the other counter. Okay, so the parent changed, the logic worked. However, obviously we have two big issues. The first one is just the visual. You can see the object is still placed on top of this counter, even though technically now it belongs to this one. And the second issue is that this counter still thinks that it owns this kitchen object. And this other counter does not know that it now owns this object. So we need to sort all of that. First, for the visual, it's actually very simple. Here when spawning, we are spawning it inside the counter top point and then setting the local position to 0. So whenever we move to a different second parent, when we do that, we can just ask that second parent to return the counter top point and move it there. So for that, let's make a function to return that. So public, we're going to return transform. So get the kitchen object follow transform. So this is going to be our counter top point. So let's return the counter top point. Then let's go into the function on the kitchen object when we set the clear counter. So over here on the kitchen object on this function, so we set the clear counter. Then let's modify this transform.parent, go into the new clear counter in order to get the kitchen object follow transform. And again, let's make sure to set the local position back into vector3.0. Okay, so with this, when we set the clear counter to a different one, it should automatically teleport to the other counter. So let's test. So here we are, and first let's interact with this one. There you go, it spawned. Now if I press the testing key, and there you go, it does move visually. Okay, great, so far so good. However, the counters still have the wrong data. By the way, here's a quick Unity tip. On the inspector, you already know that you can only see the public and the serialized fields. However, there is actually a way to look at private fields. On the inspector on the top right, there's these three dots, and if you click on it, over here you can modify it into a debug inspector. And when you go into this one, yep, this one does show all of the private fields. So you can see, for example, on the clear counter, so that's the right one. This one over here, the kitchen object, is indeed assigned. And we can go into the other one, and we can see this one has it as null. So debug inspector is really useful in these kinds of cases. If you want to inspect any kind of private fields, you can go to this and see it. Now let's swap back into the regular inspector. And let's fix that issue by notifying the counters that the object is changed. So over here, basically we have two options. Over here on the clear counter, when we modify the parent, when we tell the kitchen object to go to a new parent, when we do that, we can make the new parent responsible to updating itself, or we can just make the kitchen object itself be the one responsible for notifying the new parent. Both approaches can work. Personally, I think it makes more sense for the kitchen object to handle itself. So we just call this function to set the new parent. And when this happens, basically this kitchen object needs to tell the old parent that it is no longer there and needs to tell the new parent that it is on there. So on the counter, let's make some function to set and get a kitchen object. So over here on the clear counter script, let's go down. Let's make first one to set. So public void set kitchen object and receive a kitchen object. And just do this dot kitchen object equals this kitchen object. Okay, great. Then let's make a getter. So public return a kitchen object, get the kitchen object, and just return this kitchen object. Okay. Then let's also make one just to clear it. So public void clear kitchen object. And this one just sets the kitchen object into null. And finally, just a nice simple function to test if this counter has anything on top. So just a public bool has kitchen object. And over here, we just return if the kitchen object is not null. Okay, so some 4 very simple functions. Now, if we go into our kitchen object script, over here, when we tell it to change the parent, let's first go into the current parent and clear it. So let's first of all do a quick test for null. So if this .clear counter, which is the current parent, so if this one is not null, then we go into the current parent, so the clear counter, and we tell it to clear the kitchen object. And then we go into the new parent, and we tell new parent to set the kitchen object, and the kitchen object is this one. Now here, be very, very important, don't make the mistake of clearing the wrong counter. Keep in mind that over here, this .clear counter, this refers to the previous clear counter, whereas the one in the parameter, this is the one, this is the new one. So make sure you clear the kitchen object from the previous clear counter before you assign it, and then you set it on the new clear counter. So be very, very careful here. Make sure you don't make mistakes between the quote-unquote old clear counter and the new clear counter. Okay, so that's it. Basically, we have this function to set the new clear counter, so set the new parent. We clear the kitchen object from the old clear counter, we add it to the new one, and we update the visual. Now, we can also add some nice safety checks here, just to make sure we never make a mistake. The kitchen object should never be set to a parent that is already holding something. So before we set the kitchen object, before we do that, let's make sure that one is empty. So over here, just do an if the clear counter, so that's the new one, if this one has a kitchen object, then it already has something on there. This should never ever happen, so let's do a debug.log error and say counter already has a kitchen object. We're going to eventually add tests to make sure that this never ever happens, but having the error here will be helpful just in case we miss something. So if it has a kitchen object, we're going to fire an error, but this should never happen, so we just set the error, update the visual, and so on. Okay, so finally, let's just go over here into the clear counter script. And down here, we have the interact action. So we instantiate the kitchen object. We're currently repositioning it, and then we're setting this field, assigning it to this one. Now we made the kitchen object responsible for doing all that, for modifying the position and for setting the field, so we don't need to do this. Instead, we really just need to go and get the component of that, and just pass in set clear counter, and pass in as this one. So we no longer need all of this. Now our code is much more simple. Also importantly, up here, we were previously setting the clear counter and then doing a debug.log, but when we set it to the new one, that is actually going to clear this field. So if we leave this, then this is going to throw a null reference exception. So let's just get rid of this log here. We no longer need it. Okay, so let's test and see if all of our logic is working. All right, so here we are. Let's go to this one, interact to spawn it. Okay, great. And once again, we can look in the debug inspector. So let's put it on debug. Look at this clear counter. So that's the right one. And yep, there you go. It does have the kitchen object. And if we look in the other one, yep, this one has null. Okay, great. Now, if I press the testing key, yep, visually it did change. And if we look at the counter, so if we look at the old one, so that's the right one, this one is at null. Okay, that's great, correct. And if you look at the new one, yep, this one does have the reference. Alright, awesome! So now that we are correctly changing the kitchen object parent, for example, we can now interact again with this one, and yep, it does spawn a brand new one. And of course, if we try moving it to the other one, then we should have our error as intended. This one is currently already occupied with kitchen object, so we should not be able to drop something on there. But if I press the testing key, yep, there you go, nice error. Okay, so that's great. We're basically going to fix this error later on when we add checks to make sure the object can only be spawned when it can be spawned. But for now, all of our basic logic is working. We can spawn an object and change the parent. Alright, so with that, here we have added a really important feature to our game. That is the ability to know where a kitchen object is. Now, the next step is to enable the player to be able to pick it up and drop it somewhere, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to enable the player to pick up a kitchen object, and in doing so, we're going to learn about another awesome C# feature called interfaces. Okay, so right now with our game, I can already move the player, I can approach a counter, interact with it to spawn an object, and with the testing key, I can move it to a different parent. So all of that logic is working. Now let's make it work actually with the player. Let's say when we interact once, we want to spawn it, and if there's an object already on top of it and I interact again, then I want to give it to the player. Okay, so here on the clear counter script, we've got our interact function, and in order to make that work, we need to have a reference to the player. So let's just pass it in over here as an argument for our interaction. So just pass in the player reference. Now over here, let's do the logic that I said. So if the kitchen object is null, so if there's nothing here, then let's spawn it. Okay, great. But if there is something, then let's give the object to the player. So how we change the object parent is just like what we did up here. So let's go into that one, set the clear counter, and pass in the player reference. Except, of course, this obviously does not work. The parameter on this function is supposed to be of clear counter. It does not work with the type of player. Basically, all the logic that we built for setting the parent and changing the parent, this whole thing only works with a counter, so it does not work with any other type, so we cannot set the player as a parent. Now, to solve this problem is exactly where C# interfaces come in. Again, I have a video going through them in detail. Definitely watch it to learn everything about interfaces. Basically what it is a contract. You define some functions in the interface, and then any type can implement that interface, and you can write some code that works with the interface, which in turn means that the code will work with any type as long as it implements that interface. So in this specific example, we're going to make an interface to represent a kitchen object parent. Then we're going to implement that interface on both the counter and the player, and that way both of them won't be able to be parents of a kitchen object. So let's do exactly that. Now the first thing we do to define an interface is let's make a C# script. So let's right click, create a new C# script. And now the standard is to start interface names with the capital I and then the name. So in this case, let's name it I kitchen object parent. And let's open it. Okay, so now to make an interface, first of all, this does not extend mono behavior. Nope. And secondly, this is not a class. Instead, this is an interface. Now, like I said, an interface is essentially a contract where each class that implements that interface must follow that contract. What that really means is that you can define a bunch of functions here. By the way, quick note, you can also define properties, but not fields. I cover all of that in the dedicated interface video. But for now, here we just want some functions. Like for example, let's just put all of the parent functions that we made previously on the counter. So over here on the clear counter, a while ago we made all of these functions that we needed to make it work as a kitchen object parent. So we got the transform, set kitchen object, get it, clear it, and has it. So let's just copy all of this and paste it over here on the interface. However, one important note is on the interfaces, you don't actually include any function implementation. The implementation is up to the class that implements this interface. Although again, I should also point out another quick note. As of C#7, you can include a default implementation, but that's for more advanced use cases. So for here, let's just use the basic and not apply any default implementation right here. So we just define the function and put a semicolon. So just like this, just the function definition with the exact signature. So just like this. Okay, so now with that we have defined our interface and all of the functions that we wanted to have. With this, now let's go onto the counter script. So over here on the clear counter script. Over here, let's implement the interface. And the way we do that is pretty much exactly the same as by extending a class. So over here, we are already extending mono behavior. Then let's set a comment and let's say we are also implementing the iKitchen object parent interface. So right now you might be wondering, so is this pretty much the same thing as extending a base class? And kind of, except for one huge difference. when extending a base class, you can only have a single base class. Like for example, over here we have mono behavior. You cannot extend multiple base classes. There can only be one. However, when it comes to interfaces, you can implement as many interfaces as you want. So over here we have defined our interface, and right now we don't even have any errors. That's because we already implemented pretty much all of the exact functions. Also, Visual Studio has a really nice helpful icon over here on the left side. It is basically saying that this function, this implementation is based on the interface. But let's see what happens if I decide to comment out these functions. So if I comment out all of this, and if there we go, over here we have an error. It is telling us that this class does not implement the members for the interface. Like I said, an interface is like a contract, so you must write all of the functions included in the interface. So we must implement these, so let's get rid of the comments. Okay. With this, our interface is perfectly working over here on the clear counter. Now let's just go into the kitchen object over here on this script. For now, we're still working with the type clear counter, so let's just refactor this to, instead of working with a clear counter, let's make it work with a kitchen object parent. So let's just change this from type that to kitchen object parent. Let's also rename this, so let's use Ctrl+RR for the kitchen object parent. Then we got a function to return the kitchen object. Okay, that's good. For this one, instead of set clear counter, let's once again rename this to set kitchen object parent. And inside, again, we receive of type I kitchen object parent. Then let's also rename the parameter to kitchen object parent. Okay, so all the names here I have changed. Okay, they're all correct. We set it, we assign it. Over here instead of counter, let's say kitchen object parent already has that. So just like this. And finally down here, let's return I kitchen object parent and rename this to get kitchen object parent. And we return that. All right, so we have changed everything. I can even do Ctrl+F to search for counter, and nope, there's no instance of any counter. So all of this code has now been rewritten to work with a kitchen object parent. So like this, everything should be working exactly the same as previously. We have no errors here. And over here on the clear counter, we just have this error on the player. Let's fix this in a little bit. For now, let's just comment it. Let's just test it out to see if everything still works exactly the same as previously. Also, one final thing, since we modified the interact function over here on the player class, when we have the interact, we just need to pass in this reference. Okay, so let's test. All right, so here we are. Let's approach this one, interact. Yep, there it is. Now let me press the testing key, and yep, there you go, it does move. Okay, so everything is still working exactly the same as previously. Once again, another successful refactoring. Now here comes the magical moment. So right now, again, everything is still working exactly the same as previously, so we can only have counters as parents. But now let's go over here onto the player script. And over here, let's also implement the same interface. So let's implement the I kitchen object parent. And again, as usual, we have our error, so we need to implement this. Also again, Visual Studio is very helpful, so we can click on the light bulb icon, and let's say implement the interface. And if we scroll down here, it will automatically create all of these functions. So let's just actually implement them. So for implementing this interface, the code is really going to be exactly the same. So let's go up here into the clear counter. Let's go down, find all of these functions. Let's copy them, and on the player, let's paste them down here at the bottom. So we just need to also pick up the kitchen object as well as a reference to the top point. So over here on the clear counter, let's just grab both those. So let's just grab the kitchen object. So go into the player, and over here, let's add a field for the kitchen object. And finally, let's add another one for the counter top point. So over here, a serialized field for the counter top point. Except obviously the player is not a counter, so this name makes no sense on the player. So let's just quickly rename this and call it kitchen object hold point. Okay, here we have our new name. We've got the kitchen object, and down here, all of our functions, they're all working, no errors. All right, now let's just assign this in the editor. So over here, let's just go into our player. There's the player script and requires a reference to the kitchen object hold point. So for that, let's do it just like we did for the counterpoint. So inside the player, let's create an empty game object. Call it the kitchen object hold point. And now basically let's just position it just slightly in front of the player. So let's put it on a X of 0, on a Y of 1.3, and on a Z of 1. So there you go, just ahead, that's where the player is going to be holding the objects. Finally, over here on the player, let's just drag that reference. Okay, so far so good. Also one note here, like I mentioned previously, in order to implement the interface, it requires you to write the function code. Basically, what this means is that different objects can implement the exact same interface whilst having different implementations. So for example, over here on the player, when setting the kitchen object, perhaps over here you could play some kind of item grab animation, or maybe when clearing a kitchen object you could do some kind of logging. The only thing that needs to match perfectly is just the function signature. And the function signature, that means the return type, as well as the name and any parameters. The implementation itself, that is up to the class that wants to implement that interface. But in this case, we want it to behave pretty much exactly the same way, so like this it should be working. So we can now go back here onto the clear counter script, and okay, we have our interaction, alright, great. So if there's nothing, we're going to spawn it, and if there is something on top of it, we want to give it to the player. So now let's go into the kitchen object, and call the function setKitchenObjectParent, and pass in the player reference. And that's it, no errors, because again, this takes a parameter of type kitchenObjectParent, and the player does implement that interface, so that's all valid. Now with this, let's test and see if our code is working. Alright, so here we are, and let's interact with this counter, and there you go, the object has been spawned. And now if I interact again, yep, there you go, look at that, the player picked up the object. And since our logic is using a transform hold point as the parent, the player is automatically carrying this tomato. Alright, awesome, so this is really great. Now over here on the counter, we no longer need all of this testing code. We now have the ability to actually pick up objects from the player. So let's get rid of all this so we don't need this testing code, don't need a reference to the second clear counter or the testing. Okay, great. So here you can see the power of interfaces. By just implementing the interface, we can now place an item anywhere we want, and importantly, on any type we want. So the counter can hold a kitchen object, the player can also hold it. We could make a dog character and make it hold a kitchen object. We could make a vehicle hold it or anything. Again, interfaces are really awesome, one of the best C# features. Definitely go ahead, pause this course for now and watch a dedicated video on them. You should be very familiar with interfaces. They will help you in making all kinds of systems and games. If you want to see a clear example of the power of interface, you can go watch my How to Interact with NPCs video. That video takes advantage of interface to make sure that the player can interact with any kind of object. Alright, so thanks to interface, we can now change the parent of the kitchen object and put it on either a counter or the player. Now in the next lecture, let's make a proper different counter type. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a different counter type from where we can grab some ingredients. Okay, so far here we have our character working and we have an empty counter, and by interacting with it, we can spawn an object. But obviously that's not the behavior we want in the final game. We want different counter types that do different things. The clear counter should only be used as a place for putting down and grabbing objects. It should not spawn anything. So let's build a new counter type. And for that, one option is to make a brand new prefab and build it all from scratch. Another option is we can duplicate this counter and change a bunch of things. Or there's a third option that was added in recent Unity versions. You can now have what is called prefab variants, meaning that we can have a base counter and then we can make variants for all the types. So let's do exactly that to learn about prefab variants. Now first, let's duplicate this one just so we don't lose any changes. Let's rename this prefab to _base counter. Now I like to add an underscore just so that the base prefab is on top, since this window is sorted alphabetically. Now let's go inside the base counter. Let's go into the scene view, so here it is. And basically over here, we only want to have all of the things that all of the counters will have. So all the counters will have a box slider, all with the same shape, so that's good. They will also all have a counter top point. However, for the visual, different counters will have different visuals, so let's get rid of this. Same thing for the selected, let's get rid of this. And on the actual object, different counters will have different scripts. So let's also get rid of this. Okay, so that's it, this is the base counter. It only has all of the things that every single counter will have. So let's go ahead, save this prefab, go back outside, and now let's right click on the base counter, and go into create, and over here let's scroll down and find the prefab variant. Now let's name this the clear counter, except obviously we can't have two different names, so let's put this one into backup. We're going to get rid of this one in a little bit. So on the variant, let's name it clear counter. Let's open up this variant. And now here, let's add everything just like we had on the old clear counter. So since it's going to be exact, let's actually go inside the backup one. So here, let's just copy the visual in the selected. So let's copy this. Go back inside the clear counter variant. And over here, let's paste it. So Control V. So there it is, the selected and the visual. Finally, just a script. So over here, let's add the clear counter script. And now let's just drag the references. So the kitchen object, we're actually going to remove this in a little bit, but for now, let's assign it. The counter top point, let's drag it. And on the selected, we also need to drag the kitchen counter reference. Okay, so here is our clear counter as a variant of the base counter. So let's go ahead, save this, and go back outside. And now we can finally delete the old prefab of the clear counter. So let's go ahead and delete this. And of course, over here on the scene, we've got some broken prefabs. So let's get rid of both these. And let's drop the clear counter variant. So let's drop it, place it over here. So let's put it on X of 0, Y of 0, and Z of 3.5. Okay, so that's the clear counter. Let's just put another one to the side and perfectly on the side. So on an X of minus 1.5. Okay, now we can begin making our container counter. So for that, once again, let's make a variant. So right click on the base counter, go into create, and let's create a prefab variant. Call this the container counter, and let's go inside of it. Now here, first thing we need is the visual. So let's go inside our assets. We've got the prefab visuals. Inside we have the counters visuals, and let's find the container counter. So let's drag it inside. Again, for the local position, make sure it's all on 0, 0, 0. Okay, great. Then we need to make the selected, so let's duplicate this visual. Let's rename this to selected. Let's go inside on all of these. And let's modify the material for the selected material. So let's click on the circle icon and select the counter select material. Okay, we've got our nice little ghost icon. And just like we did previously, let's start with these disabled. So all of these game objects disabled, so they are hidden. And on the selected, let's make sure the scale is 1% bigger, so 1.01. Also on the selected, this one does not need an animator, so let's get rid of this. Now let's add the selected counter visual. And obviously for this one, we're eventually going to need to refactor it to support multiple visual objects. As you can see, this selected has multiple. But for now, just make sure that it works. Let's just drag just the first one. Okay, great. So our container counter has been built. The only thing that we need is the main logic script, so let's do that. Let's go into our scripts folder. Let's create a brand new C# script. Name it the container counter, and let's select the main game object, attach a script, and let's open it. Alright, so now here let's first think what we want. For this counter, we want the player to interact with it, and when it does, we want to spawn an ingredient and give it to the player. So that means that we're going to want pretty much the exact same behavior that we made over here on the clear counter. So when the player interacts, we spawn and we give it to the player. So let's actually copy all of this code. Let's go into the container counter, and over here, let's paste this. We just need to grab the references to the kitchen object and the kitchen object SO. So again, just like we did on the container counter, let's copy all of these references. And over here, let's paste all of them. And of course, here we have an error. In order for this to work, this needs to implement our interface. So let's do exactly that. So let's implement the iKitchen object parent. And back in the clear counter, let's just copy the exact same code. So all of these functions, let's just copy them. And on the container counter, just paste them. Okay, great. So we don't have any more errors here, so everything should work. We should be able to interact with the container counter, and we should be able to see an object being spawned on top of it. Over here in the editor, let's just make sure to assign it. So let's assign a default kitchen object. So let's say a tomato, and the counter top point. Let's drag the reference. And okay, everything else should be working. So over here on the selected, we've got the visual game object, and on the container counter, we've got this. Okay, great. So let's go outside into scene view. And over here, let's just place some container counters. So let's drag one up there. Let's place it on an X of 1.5, on a Y of 0, and Z of 3.5. And let's also place another one down here. So let's rotate it to face it upwards. Okay, so on position 0, 0, minus 5. Okay, great. And let's make them spawn different things. So on this one up here, let's actually spawn a cheese block. And on this one down here, let's spawn a tomato. So let's also modify the icon here. So from cheese block, and let's put a tomato icon. So here it is.